Assalamualaikum and salam sejahtera. So today I will be presenting a poster which is the response to oxidative stress in Listeria monocytogenes is temperature dependent. First and foremost, we will be introducing ourselves. My name is Muhammad Nazrul Faiz bin Sadek and I will be presenting the introduction part of the poster.
Assalamualaikum. And I'll be explaining the discussion part for this poster presentation.
My name is Aina Farhana and I'll be presenting the methodology used.
Assalamualaikum, my name is Tarif bin Muhammad Ilyas and I will explaining about the objective and the conclusion of this poster.
Hi, my name is Ajus Bahira and I'll be explaining about results part of this poster.
Okay. For the introduction part, the bacteria Listeria monocytogenes is a foodborne pathogen which can thrive and grow in a wide range of temperature, pH level, and high osmolality environments. Listeria monocytogenes is widely distributed and common cause disease known as listeriosis. In food industries, Listeria contamination is an issue as it can harbor in poultry meats, dairies, as well as vegetables such as enoki mushrooms and other sprouts. Disinfecting these fresh produces have become a challenge as the bacteria can be adaptive to different environments. Some of effective control measures are not viable as it may reduce or damage the goods and produces. Hence, chemical disinfectants such as hydrogen peroxide, quaternary ammonium compounds, and chlorine derivatives are used in the food industry. However, long-term use of these disinfecting agents toward Listeria monocytogenes can be concerning as most bacteria are able to adapt and acquire resistance against the stress factor.
Okay, for the objective part. Okay, the objective consists of two objectives that we try to start from this poster. The first one is to analyze the effect of oxidizing agents on the growth of Listeria monocytogen on idle and refrigeration temperatures. The second is to study the changes in HLY and CLPC expression to investigate the correlation between virulence and oxidative stress response.
It's used in this experiment. The first one is the bacteria under culture conditions. 11 strains of Listeria monocytogenes were used in the study, in which 6 were taken from poultry meat factory, 4 was taken from dairy plants, and 1 was taken from a seafood company. One single colony from each plate was stripped onto tryptophan soya agar plates that has been supplemented with 0.6% of yeast extract. A single colony from each plate was then used to inoculate 5 ml of Reinhardt infusion dose. The second method used is the conduction of the oxidative stress assay, in which the Listeria monocytogenes were grown in RPM iGrowth medium, and 10 power of 9 CFU per ml of the culture was then inoculated to 50 ml of fresh PHR growth and then incubated until it reaches the mid-exponential phase. The culture was then distributed in 10 ml and then centrifuged. Then the pellets were collected, washed, and then centrifuged again. The pellets were then suspended in 10 ml of RPM medium containing ferric citrate and also cumin hydroperoxide. The cultures were then incubated for 4 hours at 10 degrees C and 37 degrees C. Then 2 liquids were taken after 2, 3, and 4 hours for RNA extraction. The next step is RNA extraction, in which 5 out of the 11 strains were chosen. Samples were reverse transcribed and the resulting cDNAs were used as templates for the real-time PCR. Expression of Listeria lysine O gene and endopeptidase CLP ATP binding chain gene were studied. The last method used is the statistical analysis, which is used to determine the correlation between the response to temperature and also the oxidizing agents in the strains. This analysis uses the Fisher's least significant difference procedure to determine the significant differences for oxidative stress at 37 degrees C and also at 10 degrees C.
Next, for the result part, so for the table 1, it shows the results of the oxidative stress in the Listeria monocytogenes strains tested. And monocytogene strains, regardless of their origin or genetic background, were significantly more tolerant to oxidizing agents such as cumin hydroperoxide (CHP) and hydrogen peroxide (H2O2) at 10 degrees C than at 37 degrees C. The stress response was also significantly different between CHP and hydrogen peroxide, and the mean hydrogen peroxide effect was significantly higher. The strain chosen to gene expression analysis by real-time PCR. Next, for A, B, C, D, and E table, it shows the expression of Listeria lysine O gene or HLY and endopeptidase CLP ATP binding chain gene or CLPC after during oxidative stress. Transcripts of HLY and CLPC were normalized to those of the lactate dehydrogenase gene or LDH gene. Expression of HLY and CLPC after 1, 2, and 3 hours is shown relative to that before the addition of the oxidizing agents. For table A, it shows exposure to CHP at 37 degrees C. For table B, it shows the exposure to CHP at 10 degrees C. For table C, it shows the expressions of HLY and CLPC in cumin hydroperoxide at 10 degrees C relative to that at 37 degrees C. For table D, it shows the exposure to hydrogen peroxide at 10 degrees C. And the last one, for table E, it shows the expression of HLY and CLPC in hydrogen peroxide at 10 degrees C relative to that at 37 degrees C.
Our poster discusses over Listeria monocytogenes, a bacterium that can withstand adverse conditions. The studies in 2016 and 17 reported oxidative stress of Listeria monocytogenes is significant at lower temperature by increasing response to oxidative stress. This raises concerns because detergents and disinfectants used in food industries are applied at low temperature. These may favor the resistance development of Listeria monocytogenes to these disinfectant and sanitizer agents over a long period of time. There are two common disinfectants used in food industries, which are hydrogen peroxide and also CHP, meaning cumin hydrogen peroxide. And it is stated that hydrogen peroxide is more effective as listericidal agent compared to CHP. Most of the genes involved in stress response in Listeria monocytogenes are regulated by sigma beta factor, which includes CTSR protein, that is the CLP of pressure during optimal condition at 37 degrees Celsius. CLP proteins such as chaperones and protease are generally influenced by temperature. The intergenetic relation could be the explanation on how Listeria monocytogenes strains could increase their virulence at different temperature. A study by Ochai et al. In 2017 reported CLPC protein is overexpressed in some Listeria monocytogen strains at 37 Celsius, thus implicating CLPC proteins in the responses to oxidative and heat stresses. Therefore, our poster can conclude that the oxidative effect is temperature dependent. The virulence genes were more strongly expressed when oxidative agents were applied at refrigeration temperature.
So for the conclusion part, okay. In conclusion, from this study, it can be described that the effect of two different oxidizing agents at two different temperature, which is at optimal and refrigerant temperature, contemporarily on distinct genotypes of Listeria monocytogenes. From the study, the oxidative effect is favorable at 10 degrees Celsius rather than 37 degrees Celsius. Hence, the variants DPIC1 gene were more strongly expressed when applied at cold temperature or refrigeration temperatures.